Hi again, and welcome to the second in a series of videos on how to achieve reliability from data. In the first video, I discussed the nature of data. We learned that there are three kinds of data: age data, condition data, and business data, and that we include data from all three sources in the maintenance decision process. In this video, we'll zoom in on the difficult problem of data quality. Age data, with regard to quality, is by far the most challenging of the three data types. We acquire age data from the work order. For our purposes of reliability analysis, we need age data to be 95% accurate and consistent. That's a tall order, given that what we have to work with are ambiguous failure codes selected from conventional work order pick lists. Often those code choices do not fit the reality of what the technician actually observed. That can be demoralizing. It's a communication breakdown, and the result is inadequate data quality that we cannot analyze. The solution I want to show you is a radically different interface to the work order. Let me demonstrate. We'll start by locating the work order using any of the filters at the top of the list. That gets us to the work order form, which is actually the RCM knowledge tree. The failure modes that the technician needs to identify are the leaves on the tree. This is a different type of work order form from what we're used to. Each leaf, representing a failure mode, unfolds to display the other RCM knowledge elements: the effects of failure, the consequences, and the mitigating actions. With the failure mode enveloped in this way, with its entire RCM context visible, a selection error is unlikely. I'll demonstrate the selection procedure. Navigate manually or perform a keyword search. Say the tech observed that a push button failed mechanically. Notice that the tree unfolds at every appearance of the search string button. An interesting situation is that there appear to be four identically looking failure modes appearing in different areas of the asset. But the one I want is the button located in the unit ESD section. Imagine how we would probably get this wrong if we were working with a conventional pick list. As an additional check, we can unfold the leaf. We verify the effects, consequence, and mitigation tasks. We doubly assure ourselves that this is indeed the failure mode whose instance we want to report on this work order. Now right-click the leaf and hit Select. Then choose the ending event. Did the failure mode's life end by failure, potential failure, or by suspension? Now notice that the parenthesized number at the failure mode leaf has incremented by 1. Not only the failure mode, but also its enclosing failure, function, component, subsystem, system, all the way up to the equipment level. They all incremented by 1 failure mode instance. That means the work order itself displays the equipment's reliability. For example, the MTBF, at every level all the way down to the granularity of the failure mode. Needless to say, this information integrated on the work order is invaluable to the technicians, planners, engineers, and managers, all of whom seek opportunities for continuous reliability improvement. You can triple check whether you selected the correct failure mode by hitting the Failure Mode Selection tab. There you'll see a description of the failure mode, its effects, and the event type that you chose. If necessary, you can remove the entire selection and start again. So what we have just seen is a simple yet error-free failure mode selection process, one that reinforces the RCM philosophy over and over again each time a work order is closed. But is there something missing? What if the failure mode observed by the technician has not yet been anticipated in the initial RCM analysis? Or what if the tech noticed that the failure mode, its effects or consequences, are incorrectly described? What if the technician disagrees with the current mitigation strategy? Does he have any recourse? Must he accept the inaccuracies? In the complex world of maintenance information, how can he convey his immediate knowledge, experience, and insight to the organization, and do it simply, quickly, and accurately? The answer is to use the LRCM Knowledge Feedback System. Here's how it works. Say you, as the technician, observed a failure mode involving a part or group of parts. You renewed that failure mode's life. In this case, let's say you replaced a defective solenoid valve. However, when trying to complete the work order, you discover, to your dismay, that there is no leaf on the tree representing this particular failure mode. How can you close the work order and at the same time convey your knowledge so that it becomes a part of the RCM analysis? Simple. Just navigate to the next higher branch, in this case to the failure that describes the loss of function caused by the failure mode. Right-click and choose Append and Failure Mode. Now build a new failure mode that you want to suggest for inclusion in the knowledge base. Provide a reason or justification for your suggestion, and hit Save. You can check your feedback by hitting the Pending Feedbacks tab. If you need to, you can delete your entire suggestion by hitting the garbage can icon. That's all there is to it. Now let's change hats. Say you're the reliability engineer, and you're responsible for maintaining and refining the RCM knowledge base, and you want to check for pending suggestions. So you hit the Feedback Manager tab. Select the equipment type or fleet whose pending RCM suggestions you want to process. At this time, there is only one suggestion pending, indeed the one we just submitted. Start a feedback management session. Hit the Process Feedback icon. Notice in the left panel that the RCM tree expands to the location of the proposed change, that is, the failure. It's highlighted and in bold and underlined. Now you read the technician's textual justification for his suggestion and hit Next. Examine the suggested knowledge elements. As the authorized user responsible for the quality of RCM knowledge related to this fleet or equipment type, you may fine-tune the suggestion if necessary. Hit the Approve button. A new leaf has been added to the RCM tree. You can monitor the continuously improving RCM knowledge on a dashboard. The pie chart tells you that there are 26 suggestions altogether. 15 of those were modifications of a failure mode made via our suggestion feedback mechanism. 7 were new failure modes. We can track the feedback activity month by month on this line graph, and we can see the status of all suggestions displayed by each contributor. That type of recognition really motivates personnel to contribute their knowledge and ideas in a systematic improvement process. The RCM knowledge base is a valuable intellectual asset for the organization. Managers want to recognize those who contribute to it. Well, we covered a lot of concepts in this video. We learned how the Mesh Living RCM user interface, an add-on to the EAM, resolves the two major physical asset management problems that we identified in the previous video, namely how to acquire analysis-grade data in the EAM work order database, and secondly, how to systematically update the RCM knowledge base as new experience and insight emerge. In the next video, you will learn how to analyze age data, how to merge it with condition and business data. Then you will learn how to build and deploy optimal decision models. Finally, we'll see how to check our model's performance and, thereby, continuously improve our organization's maintenance decision-making capability. Thank you.